For generations, humanity stood beneath the night sky, wondering what lay beyond the tiny points of light scattered across the darkness. Every star seemed to whisper the same question: are there worlds like ours? Astronomers devoted their lives to answering it, dreaming of the day they would no longer rely on faint signals, dim shadows, or mathematical predictions. They longed to see another planet as something real, a distant world with its own sky, its own atmosphere, and its own story. Then that day finally arrived, when the James Webb Space Telescope turned its powerful eyes toward the depths of space. It accomplished something humanity had dreamed about for decades. It captured what many considered the first real portrait of another world, a planet unlike anything anyone expected. It was a world that seemed to exist where no planet of its kind should, challenging everything scientists believed about how planetary systems are formed. Yet, that remarkable image was only the opening chapter. As Webb continued exploring the galaxy, every new observation uncovered another mystery. Strange atmospheres appeared where none should exist. Impossible chemical fingerprints emerged from distant worlds. Planetary systems ignored the rules astronomers had trusted for decades. And among them all, one planet began whispering what might be the strongest hint of alien life humanity had ever encountered. But before we continue this incredible journey across the cosmos, take a moment to subscribe to the channel. Your support helps us create more stories like this, and we're working toward our goal of reaching 1,000 subscribers. Now, let's continue our story. The journey began with a world called K218b. At first glance, K218b seemed unremarkable among the growing catalog of distant exoplanets. It was simply another super-Earth, too distant to study in detail and too mysterious for older telescopes to understand. For years, it remained little more than a name in astronomical records. Everything changed the moment Webb looked at it. Instead of merely collecting light, the telescope peeled away the planet's atmosphere, layer after layer, molecule after molecule, revealing a world wrapped inside a thick blanket of hydrogen. Hidden beneath that enormous atmosphere, scientists believed, could lie something extraordinary, a vast global ocean so deep that Earth's tallest mountains would disappear beneath its waters. The first discovery came quickly. Water vapor appeared clearly in the observations. Then came methane, then carbon dioxide. Finally came the molecule that stunned observatories around the world, dimethyl sulfide. On Earth, this chemical is produced almost exclusively by microscopic marine life living in our oceans. When Webb repeatedly detected the same signature across multiple observations, astronomers could no longer dismiss it as a simple error or random interference. Suddenly, K218b transformed from an ordinary exoplanet into one of the most fascinating worlds ever discovered. Scientists imagined a planet covered by an endless ocean beneath a dense hydrogen sky, where weak sunlight filtered through thick clouds and created a stable twilight stretching across the world. If life had somehow emerged there, it would almost certainly be unlike anything on Earth. Yet it would still obey the same universal chemistry that governs every living thing we know. Many researchers remained cautious, yet even cautious scientists admitted one extraordinary possibility. If any planet humanity had discovered possessed the potential to host life, K218b might be among the strongest candidates. Before astronomers could fully absorb that discovery, Webb revealed another surprise. This time, its attention turned toward HIP 65426b. From a distance, the planet appeared to be exactly what scientists expected: a massive gas giant orbiting far from its star. It seemed destined to become another routine observation. Instead, it became another mystery. HIP 65426b is nearly 7 times as massive as Jupiter. Even more puzzling, it orbits at such an enormous distance from its star that conventional theories struggle to explain how it formed there. According to accepted models, giant planets should grow much closer to young stars, inside swirling disks of gas and dust, where enough material exists to build worlds of that size. Yet HIP 65426b sits far beyond that region, isolated in the darkness. When Webb analyzed its atmosphere, the puzzle deepened. Instead of finding the smooth, predictable chemistry expected of a gas giant, the telescope uncovered strange chemical layers, unusual temperature variations, and cloud structures that refused to behave as existing models predicted. Its atmosphere seemed restless. It looked less like a planet that had peacefully evolved around its star and more like one carrying the scars of a turbulent past. The strange evidence inspired ideas that once belonged more to science fiction than scientific discussion. Perhaps the planet had originally formed around another star before violent gravitational encounters hurled it into interstellar space, where it wandered for millions of years until another star captured it. Or perhaps it had spent ages drifting alone through the darkness as a rogue planet before gravity eventually gave it a permanent home. Whatever its true history, HIP 65426b became more than an astronomical curiosity. It became a reminder that the universe may build planetary systems in ways humanity has not yet begun to understand. With every observation, the James Webb Space Telescope seemed to deliver the same message. The universe was not becoming simpler, it was becoming stranger. Before diving deeper into the galaxy, the mystery surrounding HIP 65426b refused to fade. The more astronomers studied the giant planet, the more one extraordinary thought refused to leave their minds. Perhaps this distant world wasn't simply a bizarre exception to the rules. Perhaps it was a clue. If HIP 65426bi truly formed in a way no one expected, then maybe the universe had been building planetary systems differently all along. Maybe giant planets could travel unimaginable distances before settling into their final orbits. Maybe worlds could be assembled through cosmic processes humanity hadn't even discovered yet. The planet was no longer just an astronomical curiosity. It had become a message, quietly suggesting that the universe still held secrets capable of rewriting everything we thought we knew about planetary formation. That realization changed the meaning of Webb's first exoplanet portrait. It was no longer simply proof that planets existed beyond our solar system. It was an invitation to expect the unexpected. Every new observation seemed destined to reveal a world stranger than the last. Soon, that expectation led astronomers toward the one planet they had dreamed about for years, Proxima B. Among all the worlds discovered beyond our solar system, none inspired more hope. Orbiting Proxima Centauri, the closest star to the Sun, just over 4 light-years away, Proxima B seemed almost irresistible. It rested inside the star's habitable zone, where temperatures might allow liquid water to exist. To scientists and dreamers alike, it looked like the nearest possible second Earth. Long before Webb ever observed it, imaginations had already painted the planet in vivid detail. Some pictured deep oceans stretching beneath blue skies. Others imagined clouds drifting over rocky continents hidden beneath distant horizons. If humanity were ever to visit another habitable world, many believed this would be the destination. Then reality arrived. When the James Webb Space Telescope finally turned toward Proxima B, excitement slowly gave way to disappointment. The planet circles so incredibly close to its parent star that it disappears within the star's overwhelming glare. No matter how powerful Webb is, it cannot isolate the faint light reflected by the planet from the violent brilliance pouring from Proxima Centauri itself. For the first time, astronomers found themselves in a strange situation. They knew the planet was there. They could calculate its orbit, estimate its mass, and measure aspects of its environment. Yet, they still could not truly see it. As scientists searched for another explanation, they encountered an even greater obstacle. Proxima Centauri is far from a peaceful star. It is a volatile red dwarf that erupts with enormous stellar flares, releasing bursts of radiation powerful enough to strip away a planetary atmosphere over geological time. If Proxima B once possessed oceans or a breathable atmosphere, those violent eruptions may have destroyed them long ago. Even if the atmosphere somehow survived, another challenge remained. The planet could be tidally locked, forever showing one face to its star while the opposite side remains trapped in endless darkness. One hemisphere would endure relentless heat, while the other would remain frozen beneath eternal night, leaving only a narrow twilight region where conditions might possibly support life. That contradiction transformed Proxima B into one of Webb's most haunting subjects. It is the nearest alien world humanity has ever discovered. It is the planet future generations dream of visiting. It represents the first destination in almost every vision of interstellar exploration. Yet despite its proximity, it remains hidden behind the fury of its own star. We can detect its gravity. We can estimate its temperature. We know it exists. But its greatest secrets remain concealed beyond our reach. In many ways, Proxima B teaches one of the universe's most humbling lessons. Distance alone does not make a world understandable. Sometimes the closest planets are among the hardest to truly know, and sometimes the worlds most capable of supporting life are not the ones nearest to home. While Proxima B guarded its secrets, another planet was preparing to reveal entirely different ones. When Webb focused its mirrors on WASP 39b, astronomers believed they understood exactly what they were about to see. It was a hot Jupiter, a giant gas planet orbiting extremely close to its star, its atmosphere stretched, heated, and constantly blasted by intense radiation. Most expected a relatively simple atmosphere with predictable chemistry. Instead, Webb uncovered one of the richest atmospheric fingerprints ever recorded on an alien world. Within its skies, the telescope identified water vapor, sodium, potassium, carbon monoxide, methane, and sulfur dioxide. The last molecule proved especially remarkable because scientists had long predicted it could form through chemical reactions driven by intense starlight. Yet no telescope had ever witnessed those reactions taking place on another planet. For the first time, humanity had directly observed active photochemistry beyond Earth. The same type of chemistry responsible for shaping Earth's ozone layer was unfolding on a planet so hot it resembled a gigantic cosmic furnace. But the surprises continued. When astronomers compared the chemical abundances inside WASP 39b's atmosphere with their theoretical models, nothing lined up as expected. The proportions of the molecules refused to match predictions. Instead of behaving like a simple gas giant, the atmosphere resembled a gigantic laboratory where unfamiliar chemical reactions unfolded continuously, creating patterns scientists could not yet explain. Suddenly, WASP 39b became far more than another hot Jupiter. It demonstrated that even the harshest planets could possess incredibly complex and constantly evolving atmospheres. More importantly, it revealed that the chemistry of distant worlds is vastly richer and far less predictable than anyone had imagined. Then came another destination, one that for years had symbolized humanity's greatest hope. The TRAPPIST-1 system had long been celebrated as one of the most extraordinary discoveries in astronomy. 7 Earth-sized planets orbited a single small star, with several of them comfortably located inside the habitable zone. To many scientists, the system resembled a miniature version of our own solar system, offering multiple opportunities for life to emerge. Expectations soared. Many believed that when Webb finally examined those worlds, at least one of them would reveal the unmistakable signature of an atmosphere, perhaps even the first genuine hint of habitability beyond Earth. Instead, the telescope delivered a sobering surprise. When Webb analyzed the first 2 planets, it found no atmosphere at all. There was no protective blanket of gas, no trace of lingering air, not even the faintest whisper of molecules clinging to the surface. All that remained was bare rock, exposed directly to the relentless radiation pouring from the system's ultra-cool dwarf star. The discovery changed everything the moment the results arrived. Without an atmosphere, the first 2 worlds of TRAPPIST-1 had no way to trap warmth, no shield against the relentless radiation of their star, and no environment capable of sustaining the delicate chemistry that life depends upon. The hopeful vision that had surrounded the system for years disappeared almost overnight. What had once been celebrated as a galactic oasis suddenly appeared to be something very different. A chain of barren, sterile worlds silently circling a faint red star. For many people, it felt like a disappointment. For James Webb, however, it became one of its greatest lessons. The telescope had revealed a truth that was both simple and unsettling. A planet can appear perfect from millions of miles away, sitting comfortably inside a habitable zone and resembling Earth in size, yet still be completely lifeless. Habitability, astronomers realized, is far rarer and far more fragile than anyone had imagined. As Webb continued its journey across the Milky Way, examining one distant system after another realization slowly began to emerge. The galaxy is overflowing with planets. Everywhere the telescope looked, new worlds appeared. Some were enormous gas giants, larger than Jupiter. Others were small, rocky planets resembling Earth. Some existed as frozen spheres locked beneath eternal ice, while others were scorched by stars that baked their surfaces beyond imagination. There were worlds that may hide vast oceans beneath thick atmospheres, and worlds unlike anything our own solar system has ever produced. The universe was proving to be astonishingly creative. Yet amid this incredible abundance, one thing remained strangely absent. Not a single world had revealed an unmistakable sign of life. Webb continued discovering remarkable atmospheres, violent storms, exotic chemistry, and environments that, in many ways, resembled the conditions that once existed on the early Earth. Every observation seemed to move humanity one step closer to finding life beyond our planet. But every search ended the same way. There was still no confirmed biological signature. The contradiction became impossible to ignore. By every statistical estimate, life should be common throughout the galaxy. With hundreds of billions of stars and countless planets orbiting them, the universe seems to offer endless opportunities for biology to emerge. Yet every observation tells a quieter story. The cosmos remains silent. That silence leaves scientists facing 2 extraordinary possibilities. Perhaps life is unimaginably rare, emerging only under incredibly special circumstances. Or perhaps life is already everywhere, existing in forms so unfamiliar that humanity has not yet learned how to recognize it. Either answer would completely transform our understanding of the universe. With every new discovery, James Webb reinforces another important lesson. Having the right ingredients does not necessarily produce life. A planet may possess water, an atmosphere, suitable temperatures, and complex chemistry, yet still remain completely lifeless. Again and again, Webb has encountered worlds that seem almost perfect, almost habitable, almost Earth-like, almost familiar, and yet each one falls just short. With every planet added to the growing catalog, the mystery only deepens. The Milky Way appears filled with places where life could exist, but so far, none where it unquestionably does. Taken together, every discovery made by the James Webb Space Telescope points toward one remarkable conclusion. The universe is far stranger, far richer, and far more unpredictable than humanity ever imagined. We have encountered oceans hidden beneath vast hydrogen skies. We have seen giant planets orbiting where the laws of planetary formation suggest they should never exist. We have watched nearby worlds conceal themselves behind the violent fury of their own stars. We have discovered atmospheres so chemically complex that they force scientists to rethink how alien worlds evolve. At the same time, we have watched some of our greatest hopes fade beneath the weight of real evidence. Systems like TRAPPIST-1, once imagined as potential homes for life, have reminded us that appearances can be deceiving.